Here we go. 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 Here we go.
Hello and welcome to another Container Days. I'm Justin Garrison. We have another awesome show for you today. We got 4 sessions, all about Kubernetes, AWS, how they fit together. So we're leading up to Kubecon EU. And if you're going to Kubecon EU or attending, make sure to give us a shout out in chat so we can know. And I'll be there in person. Really excited to actually travel to Valencia and see everyone. In I don't know what we call meet space, which has not been available to us for a couple years. So today we have, for the very first segments, we have a talk about Karpenter. And Karpenter is a new autoscaler for Kubernetes. Specifically right now works on AWS, but there's definitely talks about making that work other places. And to talk about Karpenter, we have Paul and Arshad. So Paul, go ahead and say hello and tell us what you do.
Hey everybody, thanks for having me on. My name is Paul Roberts and I'm a Senior Principal Solutions Architect here at AWS. And I can't tell you how many customers have been excited to hear more about Karpenter and how it can help with cost optimization. Arshad?
Hey, good morning. This is Arshad Bush. I'm a Principal Solutions Architect here at AWS. Been here for 3 years and I work with strategic partners. And I'm excited to be here talking about Karpenter with Paul.
And for today's talk, we specifically want to talk a little bit about sort of the cost optimization of EKS, right? Like how Karpenter fits in with that story of figuring out what you're spending and reducing some of those costs in an EKS cluster. Is that right?
Absolutely. I mean, it's definitely top of mind for customers that are running EKS and they want to make sure that their workloads, they don't have excess waste, and Karpenter is a great way to solve this.
Yeah. I'll go ahead and bring in the slides because I know we have a couple things we wanted to talk about. So let me pop those into the stream here. And there we go.
Perfect. So thanks, Justin, for the intros. So from an agenda perspective, we're going to cover a couple topics, which many of you all are probably aware of. But so we're going to just quickly talk about a little bit about Amazon EKS. We're going to dive into the predominant cluster autoscaler that folks are using. And then we're also going to talk about cluster autoscaling with Karpenter. And then we're going to do a demo, which is probably why all of you are here, really.
Everyone loves demos.
So let's hop to the next slide, Arshad. Great. So starting off with Amazon EKS, I've been working with Amazon EKS for a number of years now and been working with the service team for a long time and some of our largest customers. And one of the things that's really great about Amazon EKS is that, this is a fully managed Kubernetes offering that is running in your accounts. So what AWS does is that we manage the control plane. So this is handling the API servers and etcd and managing, making sure that scales and that's fully resilient. And then the actual workers, those are running in your account. So this is where you have the complete flexibility to choose whether I want to run with GPUs, whether I want to run workloads with our HPC offerings with our Elastic Fabric adapter. So there's just a ton of flexibility here. And this is there's no forks. This is straight Kubernetes that we're running. So again, it's fully managed. And then you also have benefits where you can use EKS managed node groups, where if you want to even offload some of the lifecycle management for your workers, we do that also with EKS today. So lots of flexibility, lots of huge scale. So next slide, please. So first I want to dive into the Kubernetes cluster autoscaler. And this is what many of you are running today. And the cluster autoscaler is fantastic. So we're going to walk through kind of the workflow of what you see happening in workloads. So first we'll start off with, let's say you have a workload and that workload says, oh, I'm trying to provision, but there are some pending pods and these pods have not yet been provisioned. And so next the Kubernetes scheduler is going to say, all right, well, I see these pending pods. Now what do I do? If there's these pending pods and it has nowhere to schedule them, it's going to reach out to the cluster autoscaler. And cluster autoscaler, what's really interesting here is that it works with EC2's autoscaling groups under the covers. And EC2's autoscaling groups under the covers, it's looking at your min, max, and desired counts for the number of workers. So cluster autoscaler is going to say, hey, do we have a worker that's available where I can actually place my pods? If not, it's going to say, well, let's up the desired count. Once it ups the desired count, then Cluster Autoscaler is going to say, well, let's provision another machine. So here in this example, if you want to keep building it out a little bit, Urshad, here in this example, the pending pod said, all right, well, we actually have room for one, so let's provision one. And then we still are missing more workers on this, or more capacity on the second instance. So this is where Cluster Autoscaler is going to increase the desired count. It's going to provision another worker, and now it's going to schedule the remaining pending pods onto the second worker. Now, there's a couple things to consider here. So first, when you create an autoscaling group, our best practices are to have them, essentially homogeneous, meaning you want to have the RAM and CPU configurations, similar. So if I'm using, an M5 large, you'd want to use like an M4 large. You just want to have those configurations similar, because as the scheduler is going through, and if you have a pod, and let's say it's using, 4 vCPUs or 8 vCPUs, it's going to say, oh, I need 8 vCPUs, and it's going to go tell the autoscaler to provision another instance that matches that. And so it's very specific to the instance sizes that you're going to use. So what we see commonly is that customers, instead of using just one ASG, they will actually use multiple ASGs to do this. And when you use these multiple ASGs, number one, it actually creates some additional overhead on your part. So you might say, you know what, I'm going to have an ASG that has GPUs. I'm going to have an ASG that has ARM-based instances like our Graviton processors. You might say, I have an ASG that's going to use AMD-based instances. So you're going to have multiple ASGs to do this. And then additionally, what's going to happen is, as those pods are being deployed, the scheduler is going to say, well, hey, I've deployed them. I did what you asked me to do. But in your autoscaling group, if you have, an M5 4XL, let's say, and the pod was somewhat smaller, it's just going to keep placing those pods onto that 4XL, but you're going to have some overhead, and it's not going to right size your capacity onto your worker. And so that's one of the areas where there's room for cost optimization. So let's go to the next slide. So when we think about cluster autoscaling with Karpenter, this is where we really focus on how do we right size your workload. And the purpose of this talk today is being cost optimized by default. And this is where Karpenter really comes in and says, what's the workload that you're trying to provision within Kubernetes? And how do I ensure, I being Karpenter, the cluster autoscaler, how do I ensure that these workloads are going to be perfectly fit or right sized to your workloads? And then on the other side is, if you have underutilized nodes, well then Karpenter's going to go ahead and it's going to terminate those. So it's going to make sure that you always have the right balance to make sure that you're not overusing capacity. So let's start the build out here. So again, in the similar motion, you have these pending pods. The Kubernetes scheduler says, oh, I see this existing capacity. You know what? I see that there's room that I can put a couple more pods here. Let's build those. But then it says, you know what? I am still missing 4. And what do I do when I have these missing 4? Let's keep going. And so what's going to happen is Karpenter's going to say, oh, you know what? I know based on these 4 pods, based on your CPU and RAM requirements, I know that you're going to need, maybe this is an M5 2XL that I need to provision. And Karpenter's going to be intelligent enough where it knows, it's going to look to say, what's the best instance that I can choose to schedule these workloads, so I avoid that overhead. And what's really unique here compared to cluster autoscaler is that I don't actually have to say, well, you know what? I really love the M5 4XLs. I love the 2XLs. I love the 8XLs. Or, maybe I have other instances that, I want to use GPUs. So Karpenter is intelligent enough where it can actually go through the entire EC2 instance fleet of 400 plus different instances. And it can say, you know what, based on what you're asking for, I'm going to choose the right instance that's going to be maximized for your workload. So again, contrasting that with cluster autoscaler, if you said you want to have ASGs across 400 different instance types, you'd have hundreds of ASGs. So it'd be really difficult to do this. And then at the same time, the Kubernetes with the cluster autoscaler would have to iterate through each ASG to determine, where do I place this? Is there enough capacity? Which takes additional provisioning time. with Karpenter, Karpenter is going to reach out to the EC2 Fleet API directly and say, hey, I want this specific instance type or these specific instance types, and reach out and provision it and add it to the cluster. And so now we're going to dive in a little bit deeper, and Irshad's going to walk you through what it looks like to configure Karpenter, because you can actually get even more granular. Instead of saying, hey, I want all instances, you can get granular and pick the specific instances that you want to use. So Irshad, please take it away.
Thanks, Paul. Thank you. Appreciate it. So like Paul said, Karpenter brings a lot of simplicity for the builders, for the developers, in order for them to be more agile, and also at the same time be cost optimized when it comes down to running Kubernetes-based infrastructure. Now, Paul did mention as well that Karpenter works in tandem with the Kubernetes scheduler and the cloud provider compute. In this case, it's the EC2, the Fleet API. Now, we also heard a lot of the feedback from the customers that it's hard to manage the autoscaling groups in the cluster autoscaler that they have been using in the past. Now, for Karpenter, all we need to do is to define declaratively a provisioner that you see in the simplest form on the screen right now. It has got some specs, which I will show you during the demo as well today. In its simplest form, it has some specifications that we have to fit in. Now, this is declarative, meaning a lot of that complexity is taken away from the infrastructure teams, from the developers. They need to write this provisioner, deploy the provisioner, and then Karpenter takes the responsibility of managing and then making the optimized compute available for your workloads. So let's kind of show you, a provisioner with some of the requirements. So here we have choices. Let's say your workload, like Paul mentioned, has got the requirements of certain specific compute instances. You can define those instance types. So let's say we have about 400 plus different types of compute instances. If your workload requires, in this case, let's say, for example, M5 large, M5 2x large, or M5 4x large, you can define them using the provisioner. And if you also want to limit your compute within certain specific availability zones in a region, you can easily do that as well. So this is all what you need from the provisioner perspective. There's also a TTL seconds after empty. This is, when your pods, your workload is done, or you're removing pods, then what happens is that Karpenter watches this time, and then it makes sure that the nodes are removed after this TTL. So as of now, we just released a few days ago Karpenter release 0.10.0. It's available right now, and this is the GitHub. Feel free to join our community. We have every second Thursday at 9 PST. We have a Zoom conference where we talk to the builders, developers who are using Karpenter right now in production, and then help them if they face any issues, or if there's any roadmap item that they want to ask for, and then we get in touch with the builders directly in the Zoom meeting. So a lot of the details you'll find on the GitHub, including the the roadmap. So some of the resources which will be extremely helpful for you as a builder. We have the Karpenter site, which is karpenter.sh, and then we have written a few workshops. There are some of the links here. The EKS workshop has got a portion on scaling Karpenter, and also there's a fully blown workshop with the link here on Karpenter. Plus, there's a link to the blog post which one of the developer advocate has written on Karpenter. Pretty useful information there. All right, so let's get into a demo. Just for the sake of time, I have recorded this demo, and let me just say this for you. I just wanted to make sure that we go through most of the things. How do we provision compute, optimize compute, and then how do we, if we don't need compute, then how do we get rid of that compute? How does Karpenter help us? So here you see the provision. This is the example provision I'm using for this demo. Using on-demand capacity type, and then AMD 64 architecture, and these are the 3 different compute types that I'm actually using in this demo. T3A X large, 4 VCPs, M5 2X large, M5 4X large, just to give you the idea of what the VCP and the memory shape of these compute types are. Here's the deployment, very simple deployment, 0 replicas right now, which I have deployed, and it's a pause image on the public ECR right now. And the name of the deployment is Inflate, right? So this is right now deployed with 0 replicas. What I'm going to take you through is when we scale up the number of replicas of this deployment, right? I'm going to use certain numbers that will give you an understanding of how does Karpenter, help provision optimize compute. That's the key thing that we have to remember. So what you see on the split screen right now, logs on the top, which Karpenter emits, and then the pods, number of pods right now I'm running, there are 0 pods, and also the compute nodes. This is a basic node I started the Amazon EKS with that you see right now, which is T3A medium. And on the left, now what I will be doing is, let's say we start with scaling up the number of replicas to 2. And let's see what happens, right? We'll see logs coming from, from Karpenter on the top, and then we'll see the 2 pods now entering a pending state. And if you look at from the logs, Karpenter is launching an instance of type T3AX large. Now, if you remember, which is a 4 vCPU. So just optimize compute to accommodate these 2 parts, and then there will be other Kube system parts like Kube proxy and AWS node. So it's just enough capacity, optimized capacity that is required to scale up the replicas to 2, right? Which is really needed. That's the key important thing. And also it picks up one of the compute choices that we have provision as part of the provisioner. Also, if you look at the availability zone, is US East 1, again, which was one of the choices in my provisioner. So let's go back, and then after we reach the steady state, you'll see how fast within 60 seconds the node gets provisioned, and then under 60 seconds or so, roughly about the same, you have the pods getting provisioned. So now let's scale back down to 0. Like I said, I just wanted to take certain variations of the scaling up and scaling down. And then what happens is the Karpenter adds a TTL based on the setting, which is 20 seconds right now, to the node, which means so pods are on, it adds a TTL to the node, and then you will see very soon that TTL will be first cordoned off, and then it will be deleted. So the node is gone, right? Just in time compute, and also when it's not required, it makes sure that we're not running compute unnecessarily. So as the second iteration, what I will be doing now is, let's say I scale up to a value of 7. And there was a reason, because this is based on the different type of compute instances that I'm using. So we'll see 7 parts now getting into a pending state. And from the logs, we'll see what Karpenter has done. It has picked up M5 2X large right now, right? M5 2X large. You guys remember, it's an 8 vCPU based instance. So I'm provisioning 7 parts, plus we require some vCPU for Kube proxy and AWS node. So it's just the type of the compute instance that you require. Optimized compute. I keep on saying this to make sure we keep costs. We're focused on costs as the discussion is going on right now. So you will see that the parts are entering. So after the pending state, will be provisioned. And at the bottom, if you'll see now, the node is ready, right? Within a matter of 53 seconds. And then we have aggressive goals from the perspective of the timing. In 2022, services team is working on definitely some aggressive goals from the provisioning perspective. This number is going to come down substantially at the end of the year. So let's go back again, scale it down to 0. I wanted to take it to a number of few iterations as well, again, to give you the idea of how flexible Karpenter is, right? Again, at part of the process, it taints the node for termination based on the DL settings, which is customizable, in the provisioner, and then it deletes the node. So we're back to where we were in the beginning. Now, let's scale it up to a number of 14 replicas, and each part is 1 vCPU. So right now you will see that what Karpenter has done, in order to provision these 14 parts, it has picked up an M5 4 extra large in availability zone 1C. M5 4 extra large is a 16 vCPU compute instance with 64 gigabytes of associated memory. So again, you're seeing the variety of different types of variations that Karpenter is using. And again, we're not using auto-scaling groups, right? All we are doing is with the help of a provisioner, which is a declarative way of defining the provisioner, and then Karpenter does the rest. And same process, we'll see, how Karpenter works in tandem via the scheduler and then the underlying EC2 Fleet API to make sure that we have the compute available, and then the process of provisioning these pods, pulling the image from the registry, and then you'll see that these pods are getting deployed and get into a running state. And then after this, let's go back again and try one more kind of iteration just to make sure what happens if we go beyond the capacity of a single compute instance. First, let's go back and scale it down to the 0 one more time, and so that we can start afresh. So again, Karpenter will do the rest. It will add the TDL to the node, and then in a matter of 20 seconds, which is the setting we're set right now, it's going to remove that the compute instance, which is M4 for extra large. Now, next, what I will do is let's scale it up to a number where I need more than one instance, which is 22 replicas, right? Let's see what happens. Now, in this case, you will see, what Karpenter does, it creates 2 compute instances, as you can see here. One is M5 2x large, and then the other one is M5 4x large. So again, just to reiterate, M5 4x large is a 16 vCPU, and M5 2XL is an 8 vCPU. So I'm asking for 22 pods, which is 22 vCPUs, plus if you add the kubeproxy and AWS node, obviously that's about 125 millicore. Then it provisions the optimized compute, the combination of 2 instances here, again, which is setting in the provisioner. So this is how easy it is, for the infrastructure, for the developers, for the builders, who are specifically focusing on writing code, take those feature requests coming from their customers and being more agile, at the Kubernetes-based workloads. So let's kind of summarize this. It's basically an open source project that was started. Right now, it works on Amazon EKS, and we have aggressive feature roadmap. One of them is actually, bringing down the time it takes to provision nodes in pods. You'll be hearing more in the weeks and in the months to come. Once you get engaged to the community, you'll hear a lot of that stuff. And at this point, I wanted to turn over, Justin, if you see any questions over the chat, or any comments there, so that we can address them right now.
Yeah. Let me pull. Let me fast. I got an echo again.
I got an echo again. Hold on.
Rashad, I think that might have been you. I'm just going to mute you real fast. So there was one comment that came in about what happens if we don't scale to 0, right? We scale from up to 7 and we only down to 2. What's going to happen? And in that case, yeah, Karpenter is going to keep any of the instances that are running workloads still. It's only getting rid of instances that have no workloads on them. And it does take into account if you have daemon sets or something that would run on every node, it ignores those for this case because it knows that those pods should be running everywhere. And it's only looking at the workloads that are of other types of cron jobs deployment, something that's not part of a daemon set. And there also is, but to that point, like you scaled up, maybe those 2 last instances or the 2 last pods running are on different instances. But you should be able to consolidate those, right? Because you don't want 2 individual instances because those instances are no longer right-sized for your workload. That only applied during the scale-up. So one thing we are working on within Karpenter, and I'm pasting the link in the chat, and it's up here, is what we call consolidation or defragmentation inside the cluster. So Karpenter will constantly scan the cluster as well and say, hey, I had 100 pods, now I have 5, but those 5 are spread across 5 different instances. Let's go ahead and provision another single instance and get rid of 5 instances and make it 1, or whatever your workload needs. And so it's a concept. Absolutely come to this issue. Leave us your comments on what you want to do with Karpenter in that sense and how we can work well with what your workloads need, just to make sure that we're meeting your needs with whatever you're doing. But that's the concept that we have inside of Karpenter, is this sort of defragmentation over a cycle of, hey, we scale up whenever pods are requesting, but there's times that things change without scaling up, and we want to make sure that we're still running an optimized cluster.
So just before I know we're getting towards the end here, I just want to share something that we didn't really cover is that within these provisioners, we listed out, a couple instances just so we could show you how it was right sizing these workloads. But if you don't list, the actual instances, Karpenter is going to determine, what the best fit is. But additionally, what you can do is you can use Spot. And so what Karpenter will do is it can actually go out to the spot market to find the best instances and the best price to actually provision your workload. So again, from a cost perspective, that's just hugely powerful. You don't even have to think about it. It's just going to happen, and Karpenter is going to figure all of that out. And another thing that Irshad had covered, which I thought was really cool, is that within the provisioners themselves, like most security companies or most security teams, they have a process for patching the AMIs or rotating the AMIs when new releases come out. And so there's another parameter, which is TTL seconds until expired. And so you can set that. So that means that the actual workers themselves are going to recycle every so often. You can determine how many seconds, but we showed the example of about 30 days. And so you can set that, and Karpenter will automate that as well. So there's just a lot of flexibility with Karpenter. And so we just barely scratched the surface. So I know Justin added a couple links here where we can go a little bit deeper, but it's a super exciting project. A lot of customers are showing a ton of interest here, just because number one, the costs piece, reducing the overhead of managing all the ASGs. So it's incredibly powerful, and we'd love to hear more feedback by opening up issues there on GitHub.
And one last question I'll bring up from Bad Shell Dude. I don't have that as my login shell, but we'll see. Is there a way to have warm instances with Karpenter? And we've talked about this in the project a lot, just how people are using it. Please open an issue on GitHub to let us know your use case. A lot of times this is for even faster scaling, but sometimes there's a conflict here of, is the scheduler going to just put nodes there? Do you want to add like +1 over what you need? There's so much configuration because these aren't same size instances. We don't know what one warm instance would be. So, and if that's the right approach, because there's other things that might be using those instances. So please open an issue, let us know your use case so we can understand it a little more and figure out maybe there's a way to do that within a provisioner itself, or a way natively in Kubernetes to get whatever you're trying to do and be successful. So thank you so much, Irshad and Paul. I think we're wrapping up now. We're right at time, and